So while we're in this section 4.2 on the addition rule, I want to introduce the concept of the complement of an event formally. So what is the complement of an event? E. So let's say I got a sample space out here. This could represent something like all the cards, all the possible outcomes. And then you have some event E that you're interested in. So outside of that event is called the complement. So all the outcomes not an E. So everything that's not an E is called the complement. And we write E with a bar here. Let me put this in green here. E with a bar. This is called the complement of E. It's everything outside. So that would be like out here. This yellow area I'm shading. It's everything that's not inside of E. It's kind of like the opposite of E. So we sometimes call it not E or just E with a bar over top of it. Now, one of the big rules for probability is that when you take the probability of all the disjoint events, it has to add up to 100% or add up to 1. So if I take the probability of E, and then I add it to the probability of not E, these are disjoint events, right? There's no overlap between E and not E. And this has to add up to a total of 1. Now let's say I wanted to solve this equation for the probability of the complement. That's the green one. Probability of the complement, that's with the one with the bar over it. What I would do, I would subtract probability of E from both sides. This is just some basic algebra. Hopefully you know how to do that. And on the left-hand side, you would cancel these, probability of E and negative probability of E, and you'd be left with probability of E bar, it's the probability of the complement, would be equal to what? 1 minus the probability of E. This is a formula that you might find useful quite a bit. That the probability of the complement of E is 1 minus the probability of E. So that's probably a formula you want to write down somewhere. So I'm going to write this up top. Probability of E complement equals 1 minus the probability of E. This is just something to keep in mind. So probably we'll use that a little bit. Yeah. So let's just do some exercises. So we'll probably involve the complement now. So if a card is drawn from a deck of 52 cards, determine the probability of getting the following. Ooh, my hand is hurting. All right, number 1 here. Not a face card. So probability of not a face card. I'll write that as the probability of face card with a bar over top of it. That's called probability of the complement of a face card. So probability of not a face card. So if we're using that complement formula, we have this is what 1 minus the probability of actually getting a face card. So 1 minus, well, what's the probability of getting a face card? Probability of getting a face card. How many face cards do we have? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? We got 12 total face cards here. So probability of getting a face card is going to be 12 out of 52. So what we'll do, we'll have 1 minus, let's calculate 12 divided by 52 first as a decimal. It's going to give me 0.231 approximately, 0.231 I suppose I should probably use the approximately symbol since we rounded off that to the third decimal place. Then we're going to subtract 1 minus 0.231. It's going to be approximately 0.679. Now, another way to have done this is basically just look at all those cards that aren't face cards, right? If I zoom in here, I could count up all those cards that are not face cards. How do I do that? Okay, this button. So all these cards here, right? So that'd be, what is that? How many cards? 40, right? 40 cards if you count those up. Total of 40 cards. And that's going to be out of 52. Yeah, if you take 40 out of 52, let's just write that down. 40 out of 52, that's the other way to do it. 40 divided by 52, and you get the same thing, right? You get 0.679. So, I mean, you could do it directly that way, but sometimes it's useful to use the complement. All right, let me go back and erase that. Okay. Ooh, it's on there for good. Oh, it's not going to erase my squigglies, my yellow squigglies. That's sad. Ooh, too bad. So sad. Okay, well, I'll have to deal with it. Let's do a number 2. How about the probability of getting neither an ace, nor a number card? Neither an ace nor a number card. All right. Let's actually think about what that means in terms of Venn diagrams. So let me draw a picture. So here's my box. Here you have your sample space. So this represents the collection of all cards out there. And here you're going to have the set of aces. And then here you're going to have the set of number cards. Notice that there's no overlap. So aces, these are the number cards. There's no overlap here. So outside here, this green region here, this would be neither aces, neither ace nor number, outside in green. In the blue here, the blue would be the aces or the numbers, right? That's what the blue would be, the aces or the numbers. So it turns out that the green is the complement of the blue, right? So the probability that you get neither ace nor number, that's equal to the probability of the complement of the blue. What's the blue? Ace or number, right? Ace or number is those two blue sets together in one big set, and we're finding the complement, right? We're finding everything outside of that big blue set. Okay, so remember the formula for the complement. It's 1 minus the probability of the event, ace or number card. So proceeding with this, I'm going to have 1 minus the probability. Oh, hold up, let's erase. Let's put this in big brackets now. It's not writing, there it goes. We want to find the probability of getting an ace or a number card. So if we're finding the probability of getting an ace or a number card, we're going to have to use the addition rule since we have an or situation. So we're going to write probability of ace plus the probability of a number card. I'm going to squeeze this under here, minus the probability of the overlap, ace and a number card at the same time. So all that should be in this big bracket, this big bracket. So as I'm working this out, I'm going to start with the 1 minus, I'm going to put my big bracket here. What's the probability of getting an ace? An ace. Well, there are 4 aces, right, out of 52 cards. So I'm going to have 4 out of 52 is my probability for an ace. And then what's the probability of getting a number card? Well, how many number cards are there? Well, you have 2 through 10. So that's 9 types. And then you have 4 suits, right? So 36 number cards, right? I'll do this in, what color am I going to use here? I use blue. We got 1, oh, it's not working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, right? 36. A total of 36, we said. And we just actually counted them just to verify that. So we got 36 out of 52 number cards. That's going to be, I think we're going to use red for that. Now we have to remember to subtract. Now what color are we going to use? A purple? Ace and number cards. So minus, how many cards are aces and number cards at the same time? 0 cards are aces and number cards. So that's 0 out of a total of 52 cards. So what we're talking about 1 minus, in brackets, we're going to put 52 in the denominator, that's the common denominator, and then on top, the numerator is going to be 4 plus 36 minus 0. All right, so that's 1 minus, so when you add those tops together, you're going to get 40 out of 52. In other words, 1 minus, what's 40 divided by 52 is the question. 40 divided by 52. Oops, it should be red. There it goes. 0.679 approximately. I should be using the approximate symbol here. So when I subtract those numbers, I think you get 3. No. 1 minus 0.679. 0.231. Yeah, 0.231. So basically another way to do this, you could have counted up all your cards that are not number cards and that are not aces. So basically it's these face cards over here, right? These face cards over here, I'm highlighting in blue, are neither aces nor number cards. And that's a really easy way to do it, right? There's 12 out of those, right? 12 out of 52 cards. That's another way to do it. It's a very direct way to do it. So if you write it that way, you can write out, what, 12 out of 52. And you should get 0.231. Let's just double check that. 12 divided by 52 is about 0.231. Yeah, that's a quick way to do it. So really, sometimes the formal rules, like the addition rule and this complement rule, sometimes it's longer to do it that way. So sometimes you just think, just count things up real quick, and you can get it done without going through all these. Look at all those steps using the formal rules. Yeah. Okay, but you need to have some idea about the formal rules sometimes. Sometimes when you get into complex, really complex problems, which we probably won't do. I don't expect we'll do any really complex problems in this class, but who knows? Maybe you'll encounter something sometime. What else can we do? How about the probability of, what have I done here? Neither. Come on, write, please. It's not writing. Just quit writing on me. Are you kidding me? Let me resync this. Let's see if it works now. Well, that's a shame.